In this video, we are going to focus on integrating powers of secants and tangents. Recall, sine squared x plus cosine squared x is equal to 1. If we divide both sides by cosine squared x, we get sine squared x over cosine squared x plus cosine squared x over cosine squared x is equal to 1 over cosine squared x. But sine of x over cosine of x is equal to tangent x. So sine squared x over cosine squared x is equal to tangent squared x. Cosine squared x over cosine squared x is 1. So on the left-hand side, we have tangent squared x plus 1. And remember that 1 over cosine squared x is equal to secant squared x. And so that's on the right-hand side. So tangent squared x plus 1 is equal to secant squared x. And we're going to need that. Okay. The directions say to evaluate the integral. Let's start off with example 1, and we have the integral of tangent squared x dx. But let's go back. Notice that tangent squared x plus 1 is equal to secant squared x, right? So would it be fair to say that tangent squared x is equal to secant squared x minus 1 if I just subtract 1 on both sides? So I can write this as the integral of secant squared x minus 1 dx. Now, this is the integral of secant squared x dx minus the integral of essentially 1 dx. Now, can we think of a function whose derivative is secant squared x? Well, that happens to be tangent x. And then the integral of 1 dx is x, and then we just add c. So the answer is tangent x minus x plus c. Let's take a look at example 2. Suppose I have the integral of tangent squared x times secant to the 4th x dx. Now, if you notice, I have an even power of tangent and an even power of secant. So what I want to do is I want to save off a secant squared x because I know that the derivative of tangent x is secant squared x. So I'm going to rewrite this as tangent squared x times secant squared x times secant squared x dx. But remember, I can write secant squared x as tangent squared x plus 1. So this is tangent squared x times tangent squared x plus 1 times secant squared x dx. So let u equal tangent x du is secant squared x dx. Because I know that the derivative of tangent x is secant squared x. So this is a clean u substitution. So this is the integral of u squared times u squared plus 1 du. If I distribute the u squared inside, I get the integral of u to the 4th plus u squared du, which is 1/5 u to the 5th plus 1/3 u to the 3rd plus c. But remember that u is tangent x. So this is 1/5 tangent to the 5th x plus 1/3 tangent cubed x plus c. And that's how we do example 2. Let's take a look at example 3. Suppose I'm given the integral of tangent squared x plus tangent to the 4th x dx. Now, what I'm going to do here is factor out a tangent squared x. And when I do, I can, well, essentially factor out the tangent squared x, and inside the parentheses, I have 1 plus tangent squared x, and this is being integrated with respect to x. But 1 plus tangent squared x is secant squared x. So this is the integral of tangent squared x times secant squared x dx. Well, straight u sub. Let u equal tangent x. Du is secant squared x dx. Okay, so this can be written as the integral of u squared du, which is 1/3 u cubed plus c, but u is tangent x. And so this is 1/3 tangent cubed x plus c. That's example 3. Just going to put a box. I'm going to essentially box my answer. Example 4. Suppose I give you the following. Suppose I give you the integral of secant cubed x dx. I would be remiss not to give you a problem like this. In teaching a Math 401 class or a Calc 2 class, this would be a great question to ask. So this can be written as the integral of secant x times secant squared x dx. This is a classic integration by parts problem. So I'm going to let u equal secant x. dv is secant squared x dx. Okay. du is secant x tangent x dx, and v is tangent x. So the integral of secant cubed x dx is equal to uv, which is secant x tangent x, minus the integral of v du, which is secant x tangent squared x dx. The integral of secant cubed x dx is secant x tangent x minus the integral of secant x times, I'm going to rewrite tangent squared x as secant squared x minus 1. And then I'm integrating with respect to x. So the integral of secant cubed x dx is secant x tangent x minus the integral of secant cubed x minus secant x dx. So notice how I see the integral of secant cubed x dx on the left side, and I see the opposite of the integral of secant cubed x dx on the right side. And that's not an accident. So I'm going to write this as follows. The integral of secant cubed x dx is secant x tangent x minus the integral of secant cubed x dx. And then I'm going to go plus the integral of secant x dx. And so I'm going to take this second term here and add it over to the other side. And when I do, that makes two of them. So I have the integral of secant cubed x dx times 2 is equal to secant x tangent x plus the integral of secant x dx. Divide both sides by 2. So the integral of secant cubed x dx is 1/2 secant x tangent x plus 1/2 the integral of secant x dx. And I'm just about done. So this is 1/2 secant x tangent x plus 1/2 natural log of secant x plus tangent x plus c. And that's how we figure out the integral for secant cubed x. It's a great question to ask on an exam. And then let's finish off. This was example 4. Let's finish off with one last example. Suppose I give you the following. Suppose I give you the integral of tangent to the 5th x times secant cubed x dx. Here's another interesting question. So notice how I have an odd power for tangent and an odd power for secant. So what I'm going to do is I'm going to save off a secant x tangent x, and then my leftovers are, if I save off a tangent x, I have tangent to the 4th x left over. And then if I save off a secant, I can write this as secant squared x as my leftover. So in other words, I have secant x times tangent to the 4th x times secant squared x dx. But what I'm going to do is I'm going to write this as secant x tangent x times secant squared x minus 1 to the 2nd times secant squared x dx. I just happen to know that the derivative of secant x is secant x tangent x. So my convenient choice of u is secant x. du is secant x tangent x dx. And it's really nice. So from here, I have the integral of u squared minus 1 to the 2nd times u squared du. So if I square that out, I get the integral of u to the 4th minus 2u squared plus 1 times u squared du, which is the integral of u to the 6th minus 2u to the 4th plus u squared du. So all I did was distribute the u squared inside. And so I get 1/7 u to the 7th minus 2/5 u to the 5th plus 1/3 u cubed plus c. Now, what did we call u? We called u secant x, right? So notice u equals secant x. And so this is equal to 1/7 secant to the 7th x minus 2/5 secant to the 5th x plus 1/3 secant cubed x plus c. And that'll conclude this video for, it's on integration, and we integrated powers of secants and tangents. And we did 5 examples. Thank you.